Hello class, this is a continuation of angles of elevation and depression. Here we are. Here we have two more examples that I encourage you to pause, write down, and give it a go yourselves before watching me answer them. So here's the first one, and here is the second. You can pause this at any time and give them a go yourselves. Here we go. Let's get into it. So a ladder 3.5 meters long makes an angle of elevation of 55 degrees as it leans on a wall. Okay, this is a little bit tricky. So we have a ladder leaning on a wall. That's the information that we have. So let's draw a hypothetical ladder leaning on a wall. So let's draw a ladder. Let's say it's here. We can use our imagination. That's our ladder. We know it to be 3.5 meters long. And we have a wall. It's leaning on a wall. So here's our wall, leaning up against it. And if you can't already imagine, the wall is making a 90-degree angle with the ground. Be very worried if it didn't. Okay, so let's reread this again. So here we have a ladder and the wall. A ladder 3.5 meters long makes an angle of elevation of 55 degrees as it leans on the wall. Well, if it's making an angle of elevation, if the ladder were leaning flat on the ground and it's raised up to an angle, it must be making this angle with the ground. So let's draw another line with the ground like this, and we know that this angle here must be 55 degrees. So here is our drawing, and now we want to calculate how high the top of the ladder reach the wall. So here's the top of the ladder. They want to know how high this is from the ground. So this is now, let's put this as x. We don't know what that value is. Okay, let's see what we can come up with. From our angle, we have an opposite and a hypotenuse. Opposite and hypotenuse is sine. So sine 55 degrees is equal to x over 3.5. 3.5 sine 55 is equal to x. We can answer this by inputting it into our calculator. 3.5 sine 55, that is 2.867. Rounding it off, we get 2.87 meters. That's at 2 decimal place values that we've rounded to. Okay, let's get straight into the next one. The rope of a flying fox, in case you don't know what a flying fox is, it's the thing that you hang on to, and it's like a pulley in a rope. You fly along it, I guess. You'll see what I mean in a moment. Is 25.5 meters long and declines, or has a decline, at an angle of depression of 15 degrees to the ground. Calculate the height of the start of the flying fox. Okay, so a flying fox would start somewhere at the top here. We already know it's starting from top and bottom because we have an angle of depression. So let's say this is the top, T for top. The rope of the flying fox is 25.5 meters long and declines at an angle of depression of 15 degrees to the ground. So what this means is there's some rope attached to the ground like so, G for ground, and the rope is what you hang on to and you slide along. So this must be 25.5 meters long. Okay, and the angle of depression of 15 degrees to the ground. It's declining at an angle of depression of 15 degrees to the ground. Okay, calculate the height of the start of the flying fox. So here is the start of the flying fox. We want to calculate the height of it. So there's the start. Let's put H for height. And let's draw this like so. So now we have a triangle that we can work with. Be careful, don't be tempted to use this angle here, because we need the angle inside the triangles. In my previous example, I showed that you could use this one here. I'm going to show you a different way to think about this by extending and mirroring this question. Let's take a look here. If this were some height, it must be true that this here on the other side is of the same height, like so. And if I draw a parallel line here, or parallel to the ground, then we would have made the exact same triangle, just mirrored on the other side, like so. Can you see the triangle? It's a bit in red there. Let's use that and see what we come up with. Here we go. So this angle's on the inside of the triangle. So from this angle, we have H as opposite and 25.5 as the hypotenuse of this right angle triangle. So we have to use sine. Sine 15 is equal to H over 25.5. So 25.5 sine 15 is equal to H. So H must be equal to 25.5 sine 15 is equal to 6.599, and this would give us 6.6 meters at 2 decimal places. That concludes the second set of examples for these for angles of elevation and depression. See you in the next one. Best of luck.